at UC Merced. We're going to do a synthesis video this time using bromobenzene, going to this enamine here. So this guy's an enamine. And so this is kind of using some carbonyl chemistry in principle. So there's a couple ways of doing this, making this enamine, but I'm going to just choose one way of making it, and then you can look at other ways also that might be feasible. So first thing is I noticed that I've got a benzene ring, and now I have to get rid of the bromide and add, in essence, these two carbon atoms and make an enamine as well. So I have to kind of go back retrosynthetically to go back to find the ketone I need for that. Because I've got an enamine, means I've got to react this with a secondary amine, so I need catalytic H+, and I need to react that with dimethylamine, and I need a ketone, and I need specifically this acetophenol. So I've got to add these two carbons and get out a acetophenol. So sounds easy enough, but I've got to start from the bromide. So from the bromide, I was thinking about making this carbonyl compound through a Grignard. So the way I do it is make a Grignard first. So magnesium to make the Grignard. So we add magnesium to make the Grignard. So you make phenyl Grignard like so. And then from the phenyl Grignard, you're going to then add an aldehyde because you need to oxidize the something to get to your methyl ketone. And the alcohol that I would want to get, so from this process, kind of thinking also in reverse, is to this alcohol, and I need this secondary alcohol in order to do it. And then from there, we can just fill in the blanks in terms of what we need to go from that alcohol to the methyl ketone. So in order to do that, I need an electrophile because I've got a nucleophile in the Grignard. And so the nucleophile that I would probably need to get to this alcohol in particular is the acetaldehyde, because that will add your 2-carbon fragment, and we'll have this hydrogen as part of my aldehyde. Because if you cut this like this, it's basically the aldehyde without the pronation step, because you've got the hydrogen and the methyl group like you do in your aldehyde. And so it adds this Grignard part to it. So then you get, after an aqueous workup step, you get to this alcohol, and then to go from that alcohol to this ketone, I need a different reagent. This time we'll use sodium dichromate, sulfuric acid, and water. Could have also used PCC as well from that secondary alcohol. So there's got to be a way of going from the Grignard. You react it with the electrophile, in this case acetaldehyde. That'll give us the alcohol. Then we do an oxidation to the ketone, and then we already have this step to form an enamine. So the first key is to find out what functional group you have, then find out how many carbons you may have added, and to transform this into a Grignard that you can eventually use as a nucleophile and add to an electrophile, either ketone or aldehyde, then oxidize the alcohol to a carbonyl compound, and then do your last step, which we already outlined here, so now we can make this a complete step to go to the corresponding enamine, because that will dehydrate plus water. We'll get rid of water to form an enamine because we have a secondary amine here. So secondary amine, because we need to have at least one hydrogen on there under catalytic acidic conditions. Okay, that's it for this synthesis video.